Hey guys, today we're going to take notes from lessons 7-4 and 7-5 on 7-5. We're going to be solving equations. Hello, kitty cat. Using multiplication or division. Today's date is going to be 2/27/19. And before we do that, seems like I became a little too human on the last video. So, yes, I did write the word inverse twice when I should have said solve using inverse operations. So I'll try to correct that today when I put it in this notes. And then Sophia A., good for you, caught a math mistake I made when I was doing the one example 2, and I said it takes 43 facial muscles to frown. This is 26 more muscles than it takes to smile. How many muscles does it take to smile? And what I ended up doing is, instead of writing down 43, I wrote the number 46. So let me just correct this one. I'll put it in a bright color here. Example 2, the equation should have been 43 equals m plus 26. And then when I use the symmetric property, it would rewrite as m plus 26 equals 43. Inverse operations would be to subtract 26 from both sides, giving me the answer that m would equal 17. And the conclusion would be it takes 17 facial muscles to smile. So, sorry for that one, but life moves on. So, today we're going to talk about, again, solving equations using multiplication or division. So let me give you an example of the kinds of problems we're going to deal with. Something like 2x equals 10. So we start a problem with multiplication. Or we might have something like a divided by 3 equals 7. Okay? So we're going to talk about how we have inverse operations, that multiplication is the inverse of division, division is the inverse of multiplication, and that we can use these inverse operations to help us to solve. So let's kind of go through an example. So let me just remind you, the primary goal of all of these problems, whether it is an adding problem, a subtracting problem, multiplying problem, and dividing problem, is to get the variable alone. Why? Because we want to know what its value is. Okay? Variable alone. So we're going to solve to get the variable alone so that we know what its value is. And so let's do a little examples with these two. All right. Okay, sorry, a little roommate interruption there. We had to pause. So, let's look at this guy. Now remember what is actually going on between the 2 and the x. When we have a number that butts up to a variable, that means it's being multiplied, right? So if I'm multiplying in this problem, in order to solve this, I am going to have to do the inverse operation, and in this case, that would be dividing. Now, the way that I need you to show division is not with that old-fashioned division symbol, but as the fraction bar. So what are you going to divide by, the 2 or the 10? Remember what your goal is, to get the variable alone. If I'm multiplying 2 times x, to get x alone, I would divide both sides by 2. Guess what that's called? Division property of equality. Why? because I'm doing division on both sides of the equation. Okay? So now things change. I don't get 0 when I divide a number by itself. I get 1. Okay? And so what that property is the inverse property of multiplication. So when I multiply reciprocals, 2 times 1/2, that's the same thing as dividing by 2, is to multiply by 1/2, then I'm always going to get 1. Now, the identity property of multiplication comes into play, and we multiply 1 times x, and we get x. And on the other side, we get 10 divided by 2 is 5. So lots of properties going on just in that one teeny problem, okay? So again, we're treating both sides equally. All right, let's try that division problem we have. So we have a divided by 3 equals 7. So the inverse of division is multiplication. So we're going to multiply both sides by the denominator 3. Why? Because we want to get the variable alone. Now, the only place, that you can show the multiplication with the variable is up high like that. Now, with the number on the other side, I can multiply on the side, I can multiply underneath. I'm just going to do this. Now, why do I have to do that? Because I want to create, again, this idea of multiplying a number by its reciprocal. Okay? Because I want to get the answer of 1. So again, inverse property of multiplication. But when I was doing my math on both sides, I wasn't doing division property of equality. I was doing multiplication property of equality. Okay? So we get a times 1 is a, and 7 times 3 is 21. So that's what we're going to be practicing here on these. So we're going to do a couple of multiplication problems, and then we'll do a couple of division problems, and we'll call it a day. So I'm going to go to the next screen. Now, again, I don't know whether this is going to just take you guys 1 page to do your notes, or if it's going to take you 2 pages. That, again, is going to be up to you in how you write. So it could take you just 1. That's fine. So let's do a couple of the multiplication problems. So again, the direction doesn't matter if it's a multiplication or a division. It's simply going to say solve and check your solutions. And we've already gone over why it's important to check your solutions, or we'll say solution. Okay, so let's start with this guy. 2a equals 6. So again, we focus in on the variable, and we look at what math is happening to it. So that 2 butted up to the a means multiplication, so we're going to do the opposite, or the inverse of multiplying. We're going to divide, and we're going to divide by that coefficient 2. So let's see what that gives us. 2 divided by 2 is 1. 1 times a is a. Look at all those properties we're using. 6 divided by 2 is 3. So now I'm going to go ahead and do a check. Is 2 times 3 actually equal to 6? Yes, it is. So that's verification that the answer should be a equals 3. Okay? All right. Here comes another one. Let's do... Ooh, I'm going to be mean. Decimals. 9.4g equals 28.2. So again, I find my variable, and I look what math is happening to it. It's being multiplied by 9.4, so I'm going to divide both sides, division property of equality, by 9.4. So in order to do this, I'm going to do the math off to the side. And I have 9.4 going into 28.2. So I'm going to have to move the decimal point over till I have a whole number. So I had to do it one shift. So I'm going to do one shift here, bringing up from its new home. So 94 going into 282. So let me think about this. So if I did 3, we could be 27. I think that's the number right there. So if I guess 3 times 4 is 12, carry the 1. 3 times 9 is 27, plus 1 is 28. Bingo! We just terminated. So the answer is G equals 3. Now, to check it, we're going to see if 9.4 times, let's do it this way. Oh my goodness. My decimal point looks like a multiplication symbol. There we go. That looks more like it. Times 3. And we want to know, would that equal 28.2? So off to the side, I'm just going to multiply 94 times 3. And we get 12, and we get 27, and 1 is 28. But it's not 94, it's 9.4. So there's going to be one digit after the decimal point. And sure enough, 28.8 does equal 28.2 does equal 28.2. So that means G equals 3. Okay, you know what's coming next? Yep, fraction problem. In fact, I'm going to show you 2 fraction problems on this. So we've got 1/6 x equals 7. Okay, so we've got 2 ways to show how to solve this problem. And if I multiply the fraction times, here, let me do this way. If I multiply the fraction times the variable, I would get x over 3. So technically, this now is a division problem, right? So the inverse of dividing by 3 would be multiplying by 3. So we can do it up nice and high. And remember what happens with the 3? 3 divided by 3 is equal to 1. 1 times x equals x. And 7 times 3 is 21. Okay? And then I could check it. And I get 1/3 of 21. And does that equal 7? Well, 3 goes into itself once and into 21 7 times. 1 times 7 is 7. And yep, sure enough, I don't know what that little dot was. See if I can get rid of it. I'll have to rewrite that. Sorry about that. It does work, so that tells me, yep, x equals 21. Now, let me show you a second way of solving this problem. And I'm going to keep 1/3 as 1/3. So remember how we talked about that when you multiply reciprocals, you end up getting 1? Well, what's the reciprocal of 1/3? Remember, it's just the flip of 1/3, which would be 3 over 1. So if I multiplied both sides by 3 over 1, look what happens. This becomes 3 over 3, which equals 1. 1 times x is x. We get 7 times 3 is 21. 21 divided by 1 is 21. So again, it works both ways. So you can either, if you have a fraction, you can multiply, let's see, you can multiply by the reciprocal, that's the flip, of a fraction coefficient on both sides. So this is only in the situation where you have a fraction coefficient multiplying by your variable. You can do this strategy. Now, for some of you, you're going to say, nope, I'm going to do it the other way, and that's fine. But just know that down the line, this is going to be your best, most efficient way of solving the problem. All right, now I'm going to give you a really evil one. Here it is. Oh, 10 1/3 x equals 8. So what do we do with that mixed number? Yep, we're going to change it into an improper fraction. Remember how we do that? From denominator to whole number, we multiply. So 3 times 10 is 30. From that number, we're going to add the numerator. So 3 times 10 is 30, plus 1 is 31. And we end up with 31 over 3. So 31 thirds, x equals 8. So I'm going to use that second technique so you can see it again. I'm going to multiply both sides by its reciprocal. So I flip and I get 3 over 31, 3 over 31. Now to make the math a little easier on the right side, I'm going to give 8 a denominator of 1 so that I can see if I can just multiply across. Now look what ends up happening over on the left side. 31 divided by 31 is 1. 3 divided by 3 is 1. So 1 times x is going to equal x. Now on the other side, let's see, 8 and 31 don't have anything in common, so I just multiply straight across. 8 times 3 is 24. 1 times 31 is 31. All right, so look at this ugly check, will you? So we have 10 1/3 times 24 over 31, and the question is, does that equal, where's that division symbol come from? There we go. Does that equal 8? So first thing, we're going to take 10 1/3 and change it to an improper fraction. So 30 plus 1 is 31 thirds. We're going to multiply that by 24 31sts, and we're going to see if that equals 8. So we're going to look for anything that we can simplify by. 31 divided by 31 is 1, but on the other side it doesn't work that well. So we have 3 divided by 3 is 1, 24 divided by 3 is 8. So now when I multiply all the way across, 1 times 8 is 8, 1 times 1 is 1, 8 divided by 1 is 8, and we get 8 equals 8. So that verifies, yep, we get x equals 24 31st. Okay, I don't know about you, but let's go ahead and move on, and let's do a couple division problems. So this will probably take me a little bit of room, and I'm going to have to actually probably go on to another page. So let's start with x divided by 8 equals 9. So the key thing to remember here is you've got to multiply up high. The inverse of dividing by 8 would be multiplying by 8. Over here I can multiply on the sides. So what happens? 8 divided by 8 is 1. 1 times x equals x. And 9 times 8 is 72. So now we're going to check, and is 72 divided by 8, actually equal to 9? Well, 72 divided by 8 is 9. 9 equals 9. So, yep, x equals 72 in this problem. All right, I'm going to fit one more on this side, and then we'll do a couple on the next screen. So let's do, I'm going to be naughty. Let's do a decimal problem. So I have y divided by 1.2, or 1 2/10, equals 24 hundredths. Okay. So we're going to do inverse operations. That means we're going to multiply both sides by the 1.2. So I'm going to do it like this. Okay? So again, on the left side, 1.2 divided by 1.2 is 1. 1 times y is y. Over on the other side, we're just going to do the math. So let's multiply 24 times 12. So I get 8, I get 48, placeholder 4, 2, add up, and I get 288. However, I need to count up how many digits I have after the decimal point. 1, 2, 3. So my answer will also get 3 digits after the decimal point. So my final answer is y equals 288 thousandths. So we can test this and see if we're right. Let's do our check. 288 thousandths divided by 1.2, does that actually equal 24 hundredths? So long division here we're going to have to do. So we have 1.2 going into 0.288. I'm going to move the decimal point 1 to the right, 1 to the right, bring it up. Now 12 can't go into 2, but 12 can go into 28 twice, which is 24 with 4 left over. Bring down the 8. And 12 can go into 48 4 times evenly. So I get 24 hundredths is equal to 24 hundredths. So that verifies that, yep, y equals 288 thousandths. Okay, last one, you know it's got to involve a fraction. Let's do it. Directions have not changed, and we're going to, that's number 7. I don't know where 4 came from. Number 7, let's try that again. So you're like, hey, Rosner, we've been doing fractions. What are you talking about? Let's do fractions. As it's written, it's a fraction, right? Huh. Well, I'm going to put the fraction on the other side. Nasty me. Woo! Okay, so the inverse of dividing by 3 would be multiplying by 3. But look what you end up having over here. We have a mixed number times a whole number. Phooey. Not a problem. 3 divided by 3 is 1. 1 times y is y. Over here, what I'm going to do is convert the 1 3/5 to an improper fraction. 5 times 1 is 5. 5 plus 3 is 8. So I get 8/5, and I'm going to multiply it by that 3 over 1. Now, I don't see anything I can reduce by, so the only thing I can do is multiply straight across. So 8 times 3 is 24. 5 times 1 is 5. Now, as far as I'm concerned, this answer is just fine. Okay? So let's do our check. And here's where the check gets a little bit complicated. Because when I substitute 24/5 in for y, I end up with a fraction inside of a fraction. Ugh. So here's what we're going to do. We're going to rewrite this vertical division problem, 24/5 divided by 3, and we're going to write it as a horizontal problem. Plus, we're going to create a fraction from that whole number by giving him a denominator of 1. Then, we have to remember our fraction rules that we're going to change. So, let me actually keep this guy over here, 1 3/5. We're going to go ahead and change this from a division problem to a multiplication problem. How? I keep 24/5, 24/5. Division becomes multiplication. I take the reciprocal of 3 over 1, which is 1 over 3. Now, I realize I'm going to get a fraction over here, but on the right side, I've got a mixed number. So I am going to change the mixed number into an improper fraction, which is 8 thirds, 8/5. 5 times 1 is 5, plus 3 is 8, so 8/5. Now, look over here. We do have a 3 that we can divide out. So 3 divided by 3 is 1. 24 divided by 3 is 8. When I multiply straight across, 8 times 1 is 8. 5 times 1 is 5. Guess what? Yes, indeedy, it matches. So all of that to verify, yep, y equals 24/5. Okay, have a good time with this, guys. See you later.